So last week, or I guess it was a couple weeks ago, we talked about congruent transformations, which were translations, reflections, and rotations. And all those were things we could do to a figure without changing the shape whatsoever. My end result were congruent figures. Today, we're going to look at dilations. And it's a transformation that will result in similar figures. If you think about it, most of us, at the very least, have encountered dilations with our eyes. When we go to the eye doctor and get them checked out, they dilate our eyes. They make our pupils bigger so that they can see in, make sure nothing spunky is going on. So if you kind of remember your pupils being dilated means your pupils are getting bigger, then you can kind of remember things are going to be getting bigger and smaller when we deal with dilations. So all a dilation is going to be a transformation that results in congruent angles and proportional sides. All it is a similarity transformation. We're going to have a scale factor again, but it's a little more specific. We have a formula for it, and our formula is going to be K equals image over pre-image. If you remember from 4-9, our image comes after our transformation, and our pre-image is our starting figure. It's going to be before our transformation. So if you remember, the word pre means before. That'll help you out. Just remember, whatever we're starting with is going to go on the bottom. All right. So here's our first example. I'm going to use this picture to find the scale factor of the dilation. And my dilation is going to be from moving ABC to ADE. So I know that ABC is going to be what I'm starting with. That's my pre-image. And I'm moving that to ADE, which is going to be my image. All right, so these are the two pictures we're looking at. We're looking at ABC and ADE. So sometimes, especially with this kind of scenario, it helps us to draw our actual picture. So that's what I'm going to do underneath image and pre-image. So when I'm looking at ABC, I know that I have this entire side length. So I have 30 plus 10, and that's where this 40 comes from. Then I know my image is ADE. My image is just this length right here. So that's my 30. All right, I'm going to write down my formula. K equals image over pre-image. So all I'm going to do is I'm going to take my corresponding side lengths, which are 30 and 40, and I'm going to put them in their corresponding spots. So I know 30 is my image, so that's going to go up top. And 40 is part of my pre-image, so that's going to go on the bottom. Then, if you notice, 30 over 40 is going to simplify to 3 over 4. All you got to do. So just like in 4-9, we have a coordinate notation for dilations, except they're really, really easy to remember. All you have to remember is I'm going to multiply K by X and Y, where K is your scale factor. One thing you can do is if you're looking at it, if your K is smaller than 1, I know I'm going to get smaller. When K is smaller than 1, that's like 1/2, 0.3, 3/4. All right, so they're all smaller than 1. Normally, they are fractions. Whenever K is bigger than 1, we have an enlargement. So when K is bigger than 1, that's something like 284, 36, etc. So those are really big numbers. Small numbers, you get smaller. Big numbers, you get bigger. Just keep that in mind. All right, so here's our second and last example. We're going to use our coordinate notation to sketch the dilation and then decide if it's bigger, if my dilation is an enlargement or a reduction. So I'm going to start with my points, 0, 3, 2, 3, 3, 1, and 2, 0, and I'm going to sketch them. So make sure you have this copied down on graph paper. You want to make sure that you have at least 10 spots over here and at least 10 spots over here, just so we can fit our dilation in. So take a second, make sure you got those plots pointed. Then all I'm going to do is I'm going to use my scale factor. I'm going to use that k equals 3, and I'm going to write my formula. I know xy is transformed to kx and ky, and here my k is 3. So this works just like with our translations and reflections and whatnot. I'm going to take one of my points, 0, 3. My x is 0, and my y is 3, and I'm just going to plug that into my formula. Alright, so again, my 0 goes where my x is, and my 3 goes where my y is. Then I just simplify. 3 times 0 is 0, and 3 times 3 is 9. And I go in and graph my point. I go over 0 and up 9. Next I got b is at 2, 3. So I plug it into my formula, and I'm left with 6, 9. So I'm going to go over 6 and up 9, and I plotted my b. So now let's do c. c is at 3, 1. So I plug it in, and I simplify, and I go in and plot c at 9, 3. I'm going to have you find d. So d is at 2, 0. All you got to do is plug it in. So you get 2 times 6. Or I'm sorry. I got 2 times 3 is going to give us 6. And 0 times 3 is going to give us 0. So then make sure you got that down somewhere, because I'm going to ask you a question in just a second. But then you can go and plot that point. And then just connect your dots. If you notice, my picture ABCD is getting a lot bigger. They look exactly the same, it's just one's a lot bigger than the other. So since I'm getting bigger, and also since k is bigger than 1, I know that we're going to end up having an enlargement.